Hey everybody, quick homework help video here for page 237, 238. This is section 20, lesson 23, sections 1 and 2 combined here for the homework. So let's go through the first page, but it all starts with this example at the very top. It says the Pythagorean theorem states that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, a squared plus b squared equals c squared. Okay, and a and b are always the two smaller sides of a right triangle, and c is always the largest side, which is the hypotenuse. It also happens to be across from the largest angle, which is the right angle. The diagram shows 4 copies of a right triangle. The 3 copies have been rotated 90, 180, and 270 degrees, respectively, so you can see them in different ways. The triangles can be placed to form a quadrilateral. So if you join them together like that, right here, it forms a quadrilateral. Okay, kind of a cool design, actually. The sides of it is the longest side of each triangle. You'll notice that each one of them is the C. Okay. The small quadrilateral hole, so like this part right here, is A minus B. So I'm going to put an arrow showing that that's A minus B for each of the sides in there. And it's because this long side is A, and you're taking away the shorter side, which is the shorter side on this triangle, which is B. So you take away B from the A. So it's A minus B. So we're going to work with that, and we're going to try to talk about how we can show different things about the Pythagorean theorem with this, like how it actually works. So number 1 says, explain how you know that the large quadrilateral, the one that I've circled, is a square. Well, squares have to have 2 things. They have to have all right angles, and they have to have all the same side lengths. So we can first say that all sides are the same. And we know that because they're all C. Whatever C is, so I'll put C. That's what they are. Now we have to also show that they're all right angles. Okay. How we can show that they're all right angles is we can look at one of these, and if we know about a right triangle, inside a right triangle there's 3 angles. One of them is a 90-degree angle, and since all of them have to add up to 180, the other 2 together have to add up to 180 degrees, 90 degrees, so that they add up to 180 total. So the bigger one here goes along with the smaller one here, and together those 2 have to add up to 90, so we know that's actually a right angle. And that would be the same for all of them as well. So we know that they're all right angles, and what I just showed you is why. So that means it's a square. Let's go to number 2. Explain how you know that the small quadrilateral is a square. Okay, well, same idea. We know that it actually said that all the side lengths were A minus B. So all sides are same length again. And that's A minus B. So that's one part. Can we show that they're all right angles? Well, in this triangle, it's a right angle. And next to it, to make a line, would also have to be a right angle. Same thing here and here. Here and here. And here and here. Okay? So, all right angles again. And this one's because they form linear pairs. That's the ones that make a line and that are 180 degrees total with right angles. So if one of them is a right angle, the one next to it also has to be a right angle, because together they add up to 180. All right, let's go down. Write an expression for the area of the large square. So the large square, we know that they're all C. Sides are C, and the way to find the area of a square is just base times height, or length times width. So area would be C times C. Or we're going to write it as C squared. C times C is just C squared. So area equals C squared. All right. Now it says write an expression for the area of all four triangles. Ooh. So there's four of them. Let's just look at one of the triangles. Remember, area of a triangle. So I'll write this off to the side. Equals 1/2 times base times height, or you may have learned it as base times height divided by 2. It's the same thing. So if the base and the height for these triangles are A and B, so I'm looking at the A and the B, base and height. So we could say that area is 1/2 A times B. But now there's four of them, because there's four triangles. So let's take 4 of the 1/2 whoops, let's erase that. A times B. And if I multiply the 1/2 times 4, or 4 times 1/2, 1/2 of 4 is 2. So it's 2AB. Okay? So there's our four triangles. Now it says write an expression for the area of the small square. Well, the small square, we said it was the side lengths were A minus B. So we're going to write that as A minus B times A minus B. We actually talked about this in the lesson video a little bit, how to do that. So how do you find, how you actually simplify that? I'm going to use a different color here. You have to take the first A, multiply it by both of those things. So I'd get A times A. And then I'm going to keep my minus sign. And that would be A times B. Okay. Then I'm going to take my first one, so it's a minus A, or minus B really. I'm going to take that and multiply it by both parts. So minus A times B again, so B times A or A times B. And then minus and a negative, B times B. All right. So now we're going to go and we are going to simplify that so that it's not so long. So A times A is A squared. We have minus AB minus AB. So that's going to be minus 2AB. And then plus or minus the negative becomes plus B times B is B squared. So ultimately our area for the smaller square is all this. A squared minus 2 times A times B plus B squared. Okay, just remember that. That's for the small square. Because what we're going to do now is we're going to take those things and we're going to use that to prove the Pythagorean theorem, essentially. So if you turn the page, number 6, it says that this diagram from the example on the previous page shows the area of the square is equal to the sum of the areas of the triangles and the small square. So use those expressions that we did for 3, 4, and 5 to help us write the equation to fill in these boxes. And then we're going to simplify it all. Okay, so area of the large square. Area of the large square is, we said that was C squared. Okay, so C squared equal to the area of the four small triangles. I think we ended up with 2AB. Okay. And plus the area of the small square, which was that whole long thing in number 5 there, which was A squared minus 2AB plus B squared. Okay. So that long equation. But if you look at one thing, there is a like term that we could combine. 2AB minus 2AB. And when you have 2AB minus 2AB, you get 0AB. So they cancel each other out. So all we're left with is c squared equals a squared, so positive a squared, plus b squared. And that might look familiar because that's the Pythagorean theorem. So you can rewrite it as, in reverse, you can say a squared plus b squared equals c squared. Yay, that's the Pythagorean theorem. We just proved how to get to the Pythagorean theorem, and it was a lot of work. But really, it was just taking area of some shapes. Now, we didn't actually have numbers, but we still did it. So number 7, 8, and 9 kind of wrap up what we were just talking about and also look at it a little bit differently. It says, number 7, explain what the equation in number 6 tells us about the lengths of the sides of a right triangle. Well, for right triangles, we now know that, and we proved it again, that a squared plus b squared equals c squared. And just remember that those a and b are the legs. So they're the smaller legs. And c is always the hypotenuse. That's the largest side. All right. All right, number 8, in the diagram at the right, if the two legs of the right triangle, the two legs of the right triangle are the same length. Use the Pythagorean theorem to write an equation to relate the lengths of the legs to the hypotenuse. Explain. So this one, we're just saying that a squared, it's still a squared plus b squared, but in this case, the b is also the same as a. So a squared plus a squared equals c squared, which you could combine a squared and a squared to be 2a squared equals c squared. Okay? Because both legs are the same length, the sum of them is 2a squared instead of the a squared plus b squared. So just make sure you explain that the same lengths change it, make the equation look a little bit different if it's the same exact lengths, but it still works the same way. All right, and then finally number 9. A right triangle has side lengths a and b, and the length of the hypotenuse is c. So kind of like what we've been working with. Right triangle, a, b, c. Write an expression for the length of b in terms of a and c. So what that's saying is we know that a squared plus b squared equals c squared, but we want to get something where it's b equals something. So how can we do that? Well, we can use what we know about solving equations. I'm going to move this up a little bit. Oops. And just solve it for b. It'll actually only take us 2 steps. If we want to get rid of the a squared, we do minus a squared. Oops, now I got to change this back. We just take away that a squared, and we would have to subtract it over here as well. So it cancels out here. So you're just left with b squared equals c squared minus a squared. And then if we want b all by itself, there's this, to get rid of squared, you might remember you do the square root. So that would get us b is just equal to the square root of c squared minus a squared. So that's like a different formula that you could create based off of the Pythagorean theorem if you want to find specifically one of the legs. Okay, it's just a way to rearrange a formula. So that's just our homework help video again for page 237, 238. Hope it helped. Hope you were able to follow along. I know this is a challenging lesson, and I wanted to make sure that you guys have as much understanding as possible as we finish up this lesson and go into the last part of this lesson before moving on to the next lesson where we actually apply it and solve things with it. Okay? All right, that's all I have for today. Have a great rest of your day.